So in our next section, we're going to talk about the EtherChannel feature, or which I mentioned before is used to aggregate the bandwidth of multiple physical links in the network. Some vendors call this feature NIC teaming, where the idea is that you have different physical NIC cards and you can combine them together so when the traffic goes out to the network, it looks like it's going over one logical interface. Now, the overall goal for this feature is basically to trick the spanning tree process into thinking that the interface is one link that is bonded together based on these multiple physical links. So we're allowed to have redundant paths in the network, but we're still going to prevent loops because the router knows that, or the switch knows that when it sends traffic out, it's when it gets to the other side, it's part of the same channel. So it's technically not going to cause a loop. The load balancing for this is going to be based on the MAC address. The idea is that this is going to be a more efficient usage of the traffic load balancing than we would be able to get with this for spanning tree. Because with spanning tree, we could change the path selection based on the particular VLAN, but we can't really choose between an individual source and destination how the traffic would be sent. Some of the terms that EtherChannel uses, the first we have the port channel or the channel group. This is the logical result of bonding the physical interfaces together. So when we look at the configuration and we have this port channel interface, that's representing the multiple physical links. This is where any of our configuration changes are going to go that relate to like spanning tree path selection, or when we look at doing layer 3 routing over the channel. This is where like your IP address would go, or your access list, or your routing protocols. So from the upper layer point of view, we're using this port channel interface to access layer 2 and above. We then have what is known as the member interfaces. These are going to be the actual physical links that belong to the channel group or to the port channel. We'll see that there's some strict requirements about the configuration of the members in respect to the channel, where the ultimate goal is to make sure that each of the member interfaces has identical configurations so that I don't end up with possible traffic loops in the network. And this is why there's that very strict requirement, where we need to make sure that if we have switch 1 connecting to switch 2 through multiple physical links, that on these members, there's not some configuration that allows the traffic to leave on one physical link and then come back on the other one. And you'll see that when you go to actually implement this on the switch, there's a lot of protection mechanisms that it has built in that's going to prevent you from forming the channel if it doesn't agree on what the negotiation options are. Now, one of the nice features about this channeling on the Cisco switches is that it's not directly related to the properties of the physical underlying interfaces, which basically means that we can configure channels that are used to aggregate layer 2 switch ports. They could be either access ports or they could be trunk ports, or you could use this to aggregate layer 3 routed interfaces. So I could have the channel installed in the routing table and run OSPF or EdgeRP over it. So I'm using layer 3 routing as opposed to layer 2 switching, but the switch is ultimately going to choose how is the traffic balanced between the members based on an internal logic of the MAC addresses. Could be based on the source, could be based on the destination, could be based on both of them at the same time. There's some options that we can change for this. What this is also going to solve is a limitation of, or excuse me, not what's going to solve. One of the limitations of this feature is that depending on the particular platform that you're using, there's some limits as to how many links that you can channel together. And if you're doing some sort of platform that's using the stacking feature, which is sometimes called stackwise, versus the modular platforms like a 4500 or a 6500, depending on the physical platforms, there's some differences as to what modules can channel together and what are the individual combinations. This is kind of outside of our scope because this is a hardware feature. But if you are going to implement this in production, make sure you read the hardware release notes. And that's going to tell you what the limitations of channeling is on 6509 with this particular RSP or this particular module. For the access layer platforms like we're using, their configuration is not that complex to begin with. So we're channeling between members of the same physical switch. But when you start to have multiple chassis that you're trying to channel between, or like the stacking, that plays into what are the limitations of how the channel can actually be formed. Now, from a configuration point of view, there's a couple different ways that we can set this up, where we can allow the switches to try to automatically negotiate the channel parameters, or we can statically define them. If we want to use automatic negotiation, there's two different protocols that deal with this. The first is known as the Port Aggregation Protocol, or PAGP. This is the Cisco proprietary version. The open standard is called LACP, or the Link Aggregation Control Protocol. This is defined by an 802.3 AD standard. So this is the one that your end host would be running, like your VMware machine, or some other vendor switch. If you're trying to channel between a Cisco switch and some other vendor, you would have to use this one because it's the open standard. The end result of them is going to be the same, though, where the goal is that we're trying to get the switch based on the parameters that we define to channel the links together and to bond their bandwidth together. Configuration-wise, this is what's controlled by the channel mode in iOS, where the modes that are desirable in auto, these are going to be using the PAGP protocol. The active and passive modes, these are using LACP. The other option is to turn the channel simply on. This is like to say switch port mode trunk, where you're not using negotiation for it, you're saying that this is always going to be a channeled link. The reason that you would want to use the negotiation is that it's going to help you to prevent any misconfigurations and any loops in the network. That if I were to configure the channel as manually on, and then there ends up to be some sort of configuration problem, or maybe some sort of layer 1 problem, you can potentially end up in a loop in the network, where the traffic leaves one of the switches on one of the members of the channel, and then possibly comes back in another member, which then is ultimately going to loop the traffic between them. So this is mainly what these negotiation protocols are trying to fix. That based on these negotiation parameters, it's going to know, is it valid to run the channel, or should it be disabled until you fix the configuration to make it compatible.
Is there a preference on which setting you use?
It just depends on if they're both Cisco switches or if you need interoperability. The end result is going to be the same. So they do nearly identical things, just one has an open standard format and one's proprietary. When you look at the modes, what this is going to control is just who starts the negotiation. What this would then mean is that if you were to have two switches that are trying to channel together, if one side is on, the other side has to be on because they're not using negotiation. If one side is desirable, the other side can be either desirable or auto, because these two mean they're running PAGP. Desirable starts the negotiation, auto just listens for the negotiation. Where for LACP, the similar ones for these would be the active mode, so active to active, or active to passive. Where passive is listening for the negotiation, active is starting the negotiation. So in the end, it doesn't really matter which combination you use as long as it's one of these five. If both sides are auto, no one starts the negotiation, so the channel is not going to work. Or if both of them are passive, then neither of them are going to listen for it. And since the frame formats are not compatible, if PAGP is on one side, it has to be on the other side. Or if LACP is on one side, it has to be on the other side. The advantage of running these is also that if one of the members of the channel goes down, PAGP or LACP is going to send you either a syslog message or an SNMP trap, where you may want to know from your network monitoring point of view, if there's a physical problem in the network and one of the cables goes down, that PAGP and LACP are going to generate this notification. If the channel is on, you're not really going to know this until all of the members of the channel go away, and then the port channel interface itself goes down. So it makes it a little bit easier from a management point of view. Question?
Well, it's on both sides, right? Is it considered what? It's not LACP or PHP or something else. What?
It's just a static channel configuration, so there's no negotiation on the link. The potential problem with this is that if you mess up the config, you can cause a loop, because there's no active negotiation between the neighbors. Where if you're running PAGP, it's going to try to prevent the case where if one side's configuration doesn't match the other side, it won't allow the channel to form. But if you're 100% sure that your configuration is fine, then you could run both sides as on. So let's look at an example of this where we have 3 switches now, same type of physical topology as before, but now we're gonna bond these links together. Where on switch 1, we have multiple connections that are going over to switch 2. These are interfaces 13 and 14 on both sides. With the configuration as the network stands now, if I were to enable all of these interfaces, so if I were to go to switch 1 and say that interface range fast Ethernet 13 to 14 is active, so they're not shut down, and the same thing on the other end on switch 2, the end result of this, when we look at the show interfaces trunk, we should see that both of these ports, 13 and 14, are running in trunking mode. One of them is running negotiation. This one was running ISL. This one is statically configured as .1Q. This tells me already they're not going to be possible to be channeled together because they're running different layer 2 options. This is one of the features that PAGP or LACP would prevent for you. That when I send the encapsulation of one frame out versus the other one, when they get to the other side, we may not be able to figure out the reassembly of the frames. So essentially, the configuration needs to be identical between the member interfaces in order to be used.
So if you tried to put those in a channel group, it would bark at you?
It's going to give you an error message, right. So if I were to say interface range fast Ethernet 13 to 14 channel group, give it any locally significant number, I'll say just 1, and the mode is, let's say, desirable to run PAGP. It says it cannot be bundled. Port 14 is not compatible with port 13 and will be suspended. The reason why is that the trunk encapsulation of 14 is ISL, the trunk encapsulation of 13 is .1Q. The problem is that if you were to try to force this to be on, there's certain versions of code that would allow you to do that, but then the actual traffic flow is not going to work. So PAGP and LACP try to prevent these cases for you. Typically what you would do in order to prevent these configuration problems is the first step is that you need to disable the physical links. And the reason why is that I want to make sure both of the ends of the link are ready with the same identical configuration before I activate the interface. Because if one side forms a channel and the other side doesn't, from the perspective of spanning tree, this side may look like one single interface. This side may look like 2 separate physical interfaces, which could result in a traffic loop. And this is ultimately what we're trying to prevent, that there's multiple physical loops in the path. I need to make sure that a packet doesn't go out there and then come back in that way. So essentially, I need to make sure these configurations are identical. So I'm going to shut the port down and then simply say default interface range fast Ethernet 13 to 14. That's going to remove any of their configurations. where this version doesn't actually let me do that. So let's do this. Let's say default interface fast Ethernet 13 and default interface 14. So now basically I'm guaranteeing they have the identical configurations because they have no configurations now at this point. So once they're back to their defaults, now I can shut them down. And if we look at the show run output, they're identical. They have no config. From here on out, any configuration changes I make, I want to make sure to do it on both of them at the same time. And that's the advantage of using this interface range command, that you type the command once, but it's applying to multiple physical interfaces. So I would say channel group, again, give it a number. I'll say channel group 1, and then whatever the mode is. Say mode is desirable. This is automatically going to create my logical interface, which is the port channel. The number of the channel is going to be related to that group number, where the switches don't have to agree on the number. It's just some local value that I'm going to use for that interface. From here on out, any changes that I make on the physical interfaces, I would also want to make on the port channel. Now, in some versions, you don't have to do this, where if you make the changes on the channel, they should trickle down to the physical ports. It may work 99% of the time, but in a real environment, it's that 1% that's going to bite you. So certain versions of code, you'll apply the command here onto the logical link, and if it doesn't get applied to the physical link, then you're going to have a problem with the result of it. So to fix this as a general rule, you want to make the changes on the logical interface and the physical interfaces at the same time. This would be anything like the switch port trunk encapsulation. Maybe I want to set this to be a .1Q trunk, and the switch port mode to be trunk manually. If I were to do anything like change the trunking allowed list, I would need to make sure this matches equally on the members and the channel. Otherwise, there could be a problem with actually forwarding based on the MAC address table. So ultimately, as long as it's an equal configuration on all the members and on both sides, then the end result should be fine. But at this point, the interfaces are still physically disabled. When we show interface status, ports 13 and 14, it should say disabled. So the very last step, once the other side is configured, then I'm going to bring them up. So now on switch 1, I would do the same thing. On interfaces 13 and 14, I want to reset their config. So default interface fast Ethernet 13 and 14. This would be the same as looking at the current configuration and then issuing the no command for everything. It's just kind of a shortcut to do that. It sets the interface to its default config. So now I'll say interface range 13 to 14. Those should be disabled. The channel group command, again, the number could be the same. It doesn't necessarily have to be. And what is the mode? On this side, I configured the trunk, or I configured the channel to run in PAGP desirable mode. It means that as long as this side uses one of these two, it should be fine. So either I can listen for the other side to start the negotiation, or I could initiate it. As long as I agree on the protocol, then it's going to be fine. So I'll say here this side is auto. It's automatically generating now this logical interface. So from here on out, any additional changes I make, I want to make sure to do it on the physical links plus the port channel. Where on the other side, on switch 2, if we show run interface port channel 1, and the shortcut keyword for this is PO, show run interface PO1, I need to make sure I have this identical config on the other side. Last step then would be to activate the interfaces, simply no shutdown. So on interface range, fast Ethernet 13 to 14, and the port channel, no shut. What I should now see is that the physical layer 1 link status is going to come up for the members. Once they know that the physical link is fine, they can then negotiate the line protocol. This would be our layer 2 status. Once the layer 2 status of the members come up, we should see that the line protocol of the logical interface, the port channel, comes up.
One of the members or all members?
At least one of the members, but ideally it should be all of them. So if we show interfaces status, the port channel should show as connected. If we were to show IP interface brief, the port channel should show what? It should show up, up. If there's some sort of problem with the members, it might be up, down, or down, down. The final verification for this would be the show EtherChannel summary. This shows me what are the different channels that I'm using. I have group number 1. I could have other ones. What is the mode of the channel? Capital S here means it's a layer 2 switch port. Capital U means it's currently being used. The negotiation protocol is PAGP, which means it has to match the same on the other side. These member interfaces are capital P, which is in the port channel. What I would not want to see is that these have I as standalone or lowercase s as suspended. That would mean there's some sort of incompatibility between the two of them. But if these are P on this side and I'm using negotiation, it should mean that the other side has agreed with it. Where the problem is that if you don't use negotiation, so if I said the channel was on, one side could be channeling and the other side doesn't know about it, and that's when you could cause a loop in the network.
If one of those ports was hard down, like got unplugged or something, would it show as down or would it show as one of the incompatible?
It probably would show as down.
We shut down one of the...
So let's say on switch 1, if I were to shut one of these down, it means that the link status on this side is going to go down. Then when we show EtherChannel summary, it says the port is down. So this is a layer 1 link status is down.
What if you show IP interface?
If I show IP interface brief, it would show the port channel is up. Because as long as the port channel has one active member, it's considered to be in use. But this is the reason that you would want to run, another reason why you would want to run PAGP, that when I shut this physical port down, there was a link down up notification, which is normal, but there was no log message that said the EtherChannel reported anything. So from a management point of view, I don't know that one of the members went away. But if I was doing SNMP trapping for PAGP itself, that would tell me. It would say one of the members of the channel went down. It gives you the specifics about what this is. So if I show EtherChannel summary, it should say now that they're both in the port channel, capital P. Now at this point, I also have the channel configured as a layer 2 switch port. And the switch port is in trunking mode. This means that if we were to verify the layer 2 spanning tree, we should see that the PO1 interface is part of the spanning tree topology, not these physical interfaces. And this is one of the final verifications you would check as the result of your config. That if I show spanning tree, it says that the PO1 interface has a cost of 12 and it's a forwarding port. This here told me that I had two 100 megabit per interface links that were channeled together to get a result of 200 megs. because notice that the spanning tree cost here is lower than the normal fast Ethernet interface. So the channel reports to either the layer 3 routing protocol or to the layer 2 spanning tree process that it has a bandwidth value of 200 megabits per second now as opposed to 100.
How does that translate to 12?
As the bandwidth goes up, the cost goes down. It's not a linear relationship though.
It's not like the half of the 19 or something.
No, it's not half of it. So as the bandwidth goes up, it slowly approaches 1
Okay.
as the minimum cost.
If one of those ports goes down, does the cost change?
The cost will change automatically. So when you look at the show interface port channel, the bandwidth attribute, this is based on the members that are in the channel. So if I wanted to add another member to the link, there's actually another physical link that goes between the two of these, which is FA0/15. If I add this to the channel on both sides, I should see that the channel is going to update its bandwidth value to 300,000 kilobits per second. Then from a spanning tree point of view, this cost should go down further.
Do you, to modify the priority, do you do that on the port channel or all?
It would be on the port channel. So from here on out,
You wouldn't do any config for that on the physical interface? The two?
to be safe, you really should do it on all of them. Because there's some things like the channeling config, this definitely goes on the physical interface, this command. But you would normally figure that these two features, because this is kind of a logical option, would go on the port channel. But if this is not on the physical link, they become incompatible. So instead of trying to memorize which options you need on the member versus the channel, you just do identical configurations on all of them, and then it's going to work 100% of the time. Sometimes you'll see if you enter the commands on both, the router or the switch will remove it on the one that doesn't need it, which is fine. Question?
In the past, I saw some people put your port fast on the EtherChannel. Would that create any major problem?
You can configure port fast on it, but it depends on what the channel is used for. Between the switches, you would not want to do that. But if you were channeling to a server, then it would make sense. So if you have like a VMware machine that is doing NIC teaming, exactly. So I think the HP servers call this NIC teaming, where you try to bond the physical NICs together, then it attached to the switch. Normally you would do this with LACP, because then you could negotiate it with the server's NIC cards. Then when this binds together, you're not running spanning tree on the port, so you would want to configure it as an edge port. But then the advantage is that if your server is attached with Gig E, just by adding another NIC card, you increase the physical capacity to 2 gigs as opposed to 1. So let's add that other interface and look at the result of it. What I would want to do here is go to the interface and first always shut it down. This is going to make sure that once I'm finally ready to add it to the channel, that the configuration on both sides matches what the other ones have. And the reason why you need to do this is that the regular iOS, as soon as you enter a command, it immediately applies. So it doesn't have like a commit option like iOS XR does or like Juno OS does. So the problem is that if I'm entering these commands here on this side and the interface is up, this side tries to channel before the other side is ready, and that's when you end up in the incompatibilities. So it's always safest to put the link as administratively down, add all of the options, then as the last step you bring it out of shutdown state. So the same thing on this side. I want whatever is on port 13 to be on port 15. So on Fast Ethernet 15, I'll shut this down add those options, then I could bring it up. If we show EtherChannel summary, I should see that this link is going to transition from the D, right now it's down. This should change to a capital P, that it's in the port channel. So let's look at the show interface fast Ethernet 15 status. It says it's not connected. This probably means what? Assuming there's no physical cable problem. It's probably shut down on the other side. Here it says it's not connected as well. Let's link is down, line protocol is down, it's not connected. Let's look at the show run. It's got the same config on this side. And it's got the same config on the other side. This actually may be a physical problem. Let me try this first. On the port channel interface, if I disable this, it should turn the member interfaces off as well. But it didn't add 15. So let's do this on both sides. This side it did. So for some reason it wasn't part of the channel on this side what it was the other. And you'll see there's some of the different hardware platforms have different caveats with this, which is why it can be really, really sensitive to the order that you put this config in. So let me do this now. Let's say so this is desirable, desirable, desirable. This side is auto, 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 which should be fine. Because desirable is starting the negotiation, and then auto is listening for it. As long as all three of these agree, and then all three of these agree, it should be fine. So let's do this next. Let's go to all three at the same time. Interface range, fast Ethernet 13 to 15, and the port channel, and shut all of them down. This is going to make sure that they all try to initialize at the same exact time. Then no shutdown. This is probably a physical problem then.
On which one?
Showing the interface at 15 give you anything?
Not connected.
It's not connected, so it's probably just a cabling problem.
But your channel should have still came up, shouldn't it?
Not if there's a layer 1 problem. So layer 1 has to be working first before it can send it to the channeling process, which probably means that there's something wrong on this side where...
So the channel has to come up at least once on all members before...
Well, this is the advantage of running it, that as long as one of the members is up, the channel is up. So the idea is that you can gradually add new physical links as you need extra bandwidth. That you're supposed to be able to add them gradually like this. So if we do it, let's try it on the other side. Let's try it between switch 1 and switch 3. This should be interfaces 16, 17, and 18.
But right now, is the port channel considered up?
The port channel is up because at least one member is up. But there's a problem with one of the physical links then.
Yeah.
So let's look at on switch 1, if we show EtherChannel summary, even though this link is down, as long as one of them is up, the channel is going to be working. So from the perspective of the spanning tree process, if we show spanning tree VLAN 1, as long as this shows up here and not the physical links, it means the channeling process is working. Because again, at layer 2, the idea is that we're trying to hide the details from spanning tree, that there's multiple physical interfaces there. If we were doing layer 3 routing, and I went to the port channel and said no switch port, I would also have to convert the physical interfaces. And let's look at this between switch 1 and switch 3, how to do a layer 3 version of this, where it's basically the same. I would say, first off, default interface range, fast Ethernet, 16 to 18. This is going to set all of those back to the defaults. If I look at the configuration now, 16, 17, and 18 should have identical configs. Okay, so right now they're blank. What is also a good shortcut for this is to define a macro that is for that channel plus the members. So if I were to say define interface range macro that is, let's say, port channel to switch 3. Channel to switch 3. This is fast Ethernet 0/16 to 18 and port channel 2. And that doesn't exist yet, so I can't do that. Let me create it. Let's say interface port channel 2. Now from here on out, if I want to make a change, I would say interface range macro channel to switch 3. Now I'm guaranteed that any changes I make is always going to be the physical links plus the channel at the same time. So this is just a shortcut. You don't necessarily have to do it this way. It makes it a little bit easier to manage sometimes, though. So I want to shut those down. On the other side, there are different physical links. There are 13, 14, and 15. 13 to 15. But as long as I know I have some unique channel number, it doesn't really matter. If I now say define interface range channel to switch 1 is fast Ethernet 13 to 15 and port channel 2. Now as long as I can remember what this is called, then I don't need to worry about what the physical underlying topology is. So I'll say interface range is the macro channel to switch 1. And shut those down. Okay, now I'm going to do the channeling config. This is going to be a layer 3 interface, which means that the port channel is going to have an IP address directly assigned. Then when we look at the output of show IP route, you would be able to run regular layer 3 routing over it. So to do this, first thing I need to make sure that all of the interfaces are not switch ports. I'm turning them into layer 3 routing mode now, as opposed to layer 2 switching mode. They're all going to be part of the same channel group. Channel group 2, mode, let's say we use LACP. We'll say active on this side. This command doesn't make sense to add on the channel itself. So it's giving me an error because I tried to do it on the range. What it should do, though, is still apply it on the other interfaces where that was valid. So it's fine. It still applied it here, but it didn't add it on the channel group because that's not a valid command. But that's okay. I can now go back to the port channel interface. This is now where any of the layer 3 configuration would go, like an IP address between them. Let's say 100.0.0.1 for switch 1. Then on the other side, we would have the same thing. We would say for the interface range, no switch port, so that's turning them into layer 3 mode. They're in the channel group. The mode could be either active or passive, as long as they agree on it, because this side I have it configured as active, which says to run LACP. So say this side is passive. Channel group 2 mode passive. That is a parser bug. Let's try this.
Accepted on the range, but not on.
It's a bug. It should accept it, but it doesn't. On the other side, it did accept it, so they're probably running 2 different versions. Then on the port channel, this is where the address would go. So I'll say 100.0.0.3 for switch 3. As the last step, once the channel is activated, it should now activate the physical members. And if the routing process is on, if I were to say IP routing, the final verification for this would be to look in the routing table. That if this shows up as a layer 3 interface, when I send IP packets to the link, the MAC address is going to point at one single value on the other side. But then the layer 1 and 2 process of EtherChannel is going to figure out how do I break those packets up to send them between the members. So the advantage is that from the routing protocol point of view, I don't need to do any load balancing like for OSPF or EHRP or whatever the other protocol is. It's now taken care of at a lower layer with layer 1 and 2. If we show EtherChannel summary, I want to make sure that all 3 of those members are in the channel, which this one is not. These 2 are fine, but this one is not. The other different output that this shows here is that this is a layer 3 channel. This is a routed interface. But the end result is the same, that the EtherChannel process is just in charge of bundling the links. Whether you're doing switching over it or whether you're doing routing over it, it's not part of the channel software's job.
I wonder what's the data flow over it. Like, is it using one port for the first packet, the second port for the next packet?
We'll talk about that just in 1 second here. Something is probably wrong with my physically cabling on this rack, because now this one is down on both sides. The link is 16, 17, 18 is down as well. CDP is not going to show anything because the physical link status is down, which is fine. Normally this wouldn't be a problem. This is like a layer 1 troubleshooting that would be related to it. If you look at this and it says that the link is down, there's really not much that you can do from the router at this point. It's something physical with layer 1. Like if in this case they're copper interfaces, I'd want to check, is the link light actually on? And probably not. It's probably like the cable is loose in the rack room here.
What about the ASIC? Create an issue with the ASIC and the port?
It's possible, but then at that point you have to go through kind of like your layer 1 process of elimination. Swap out the cable, see if that fixes it. If that doesn't fix it, move it to a different port and see if that link light comes on. And then if that doesn't work, swap out the platform, see if it was related to that.
Way that you check the hardware since we're not physically there, just to see if it was a hardware issue.
Not really. So at this point, remotely, there's not anything that you can do with it. So again, the final verification of this one, since we're running layer 3, is to look at the routing table. And if I were to ping 100.0.0, oh, you know why? I'm on the wrong rack. That's why. There's no physical cables between those two. This is not the same rack I was working on before. I opened up the wrong section. But if I were to ping 100.0.0.3, simply based on the fact that I can send IP packets between them, the channel is working. Now, behind the scenes, the way that the channel is going to be sending the traffic, this is there. I was on the wrong rack. If we show EtherChannel summary, okay, that would do it. That would be the reason why. Depending on the individual platform, you'll see some different options under the port channel load balance command. And this is actually a very important point of the logic of how the channel works. Depending on what particular platform you're using, they're going to have different defaults for this. So this particular platform, if we do show version, include iOS, this is a 3560 that's running version 12.2.46 SE. So what I would want to do is correlate for the specific command reference of this version, what's the default option here? The way that you would do this is under the product documentation. You go down to configure. Then since these are the switches, these would be under products switches. This is a LAN access switch. It's a 3560. Then under the reference guides, this is where the command reference is. So I need this specific release, which is 12.2.46 SE, because this stuff can change between sub-releases. Then this is the port channel load balance. So these are just in, most of these are in alphabetical order. Port channel load balance. It says for this particular version, the default is source MAC, where source MAC says load distribution is based on the source MAC address. Packets from different hosts use different ports in the channel, but packets from the same host use the same port. The reason that this is important is that when you look at the actual traffic patterns of your application, let's say that we have some database server that we're doing replications between. And this is attached at the access layer. This is where switch 1 is channeling its multiple interfaces. Maybe it has 3 gig E links that it's channeling together to a 3 gig link, and it's channeling these over to switch 2. Then eventually somewhere in the rest of the network, we have some host that we're trying to reach this application. You need to now think about, when you look at your application flows, what is the majority of the traffic in that pattern? So if I have a database server that's doing massive replications down to these end hosts, when the switch receives the traffic, is the majority going in this direction or is the majority going in this direction? It really depends on what is the application. But let's say in this case the majority of traffic is going from the database server to somewhere else. The problem we would run into is that when this switch receives the traffic, the source MAC address is always going to be the same. So it means that when the switch makes its decision, it only picks one of the physical links of the channel. The end result of this is that this link would be a very high utilization, where these other links would be a low utilization. And sometimes it's hard to troubleshoot why is it actually doing that, where you would figure I should be able to get up to 3 gigs of throughput, but based on the load balancing behind the scenes, that's not how it ends up. And that's why they give you a bunch of different options for this. That you want to set it to some value, that it ends up to be a more equal distribution based on the traffic patterns. So you could just change it to maybe the destination MAC address and that's going to fix it. But if you don't get as much of an equal distribution as you want, then you could start to say, well, include the IP address in there. Or do a binary XOR between the source and the destination IP address to try to get into a case where you just randomly choose different links depending on where the traffic is coming from and where the traffic is going to. But the only way that you're going to see this mainly is that if you have some sort of network management application that actually looks at the utilization of the interfaces. So when you look at the show interface port channel, and I don't actually have it configured here, but if I show interfaces, let's say Fast Ethernet 13, 14, and 15, what I would want to know is what are the number of either packets being input and output or the number of bytes. For the layer 2 switch, I'm probably more concerned about the bytes because I'm looking at the bit per second value, not necessarily the packet per second value. So I want to know what is this number. I would then need to sample this over a period of time and basically look at the bytes in or the bytes out over time and look at when I sample these, maybe I sample these at 5-minute intervals. I want to look at what's the change between my first sampling and my second sampling, or what we call the delta, the difference between the two of them. You look at where was the counter here and where was the counter here. If you take the difference, it's how many bytes were received in those past 5 minutes. And you keep doing this sampling over and over and over, this is going to give you what the average utilization of the interface is. This is what an application like Cacti would do for you, or tons of other network management applications. This is just one that gives you like a graphical flow to see what's the link utilization of the port. This one is nice because it's open source, it's free. But then you would need to look at the difference between the physical links. Then if one of the members of the channel has high utilization and the other ones have very low utilization, it means that you need to change this, whatever the type of load balancing that port is using.
But all of these options are session-based. You can't do packet-based.
You can't do packet-based because it's doing layer 2 switching, not layer 3 routing.
Right.
Yeah. So on the routers, when you look at the Ceph process, which is the Cisco Express Forwarding switching path, if you say show IP Ceph exact route, and these platforms don't allow you to do it because these are lower level ones, but some of the higher level platforms, it'll ask you for the source IP address input, like 1, 2, 3, 4. So where did the packet come from? Where did the packet go to? But then it'll also ask you, like, what's the protocol? Is it TCP? What's the input port? What's the destination port? And then it shows you what's the result of the switching calculation, or what physical link did it choose. So some of the higher layer routing platforms can do a layer 4 decision. With these particular switches, since they're just access layer switches, they're going to do it based on either just the source or destination IP, or try to mix it up here with that binary XOR. Okay, any questions on this feature here, the EtherChannel?
Yeah, are the CAM entries the same for each port that participates in the channel?
I want to say that they're going to be separate. And let's see, how can I check this? Let me add this configuration in here real quick for these switches. So on the interface range, 13 to 15, again, the first thing I want to do is shut these down. They go into the channel group. Then on the range of them plus the channel, we'll say switch port, trunk encapsulation, .1Q, switch port mode trunk, and then no shutdown. As you can tell, I spend way too much time on these routers. So switch 1 and 2, they should be channeling over those links now, 13 to 15. If we look at the show EtherChannel summary, all those members are in the channel, so now that third port is there on this topology. It's a layer 2 switch port, it's in use. If we look at the actual traffic pattern, there should be between these three, so there's the 3-port channel, there's router 1 over here, and there's router 2 here. Let's look at what is their VLAN assignment. Router 1 is in VLAN 40, and let's see if it can reach router 2. Okay, so they have connectivity. Let's look in the CAM table now, the show MAC address table for the dynamic entries of VLAN 40, shows it in the port channel. So it's even hiding the details from the layer 2 path selection. So when it figures out that the MAC address is reachable over the channel, internally it's going to send it to the channeling software saying, you actually figure out which physical link it goes to. That's not really the job of the higher layer switching features. So this would be something similar to what our final configuration would look like. That they agree on what's the type of protocol they're running. In this case, this would be for PAGP on both sides. As long as the individual options of the channel then match, like this side is an ISL trunk, that side is an ISL trunk, then they should be able to form the channel end-to-end. Then the outside of the configuration verification, show EtherChannel summary is going to show you the details of what's going on behind the links.